I was looking for a material that could simplify the building and allow to achieve a solution that doesn't need many techniques and many materials with all the complications that result out of it. On the one hand, but on the other hand, it was also a really, let's say, architectural reason in that sense that for this particular project I was looking for a building envelope that combines a sort of shell-like nature, kind of protecting element, and combine that with a big openness of the building. And then I came across the possibilities of this particular insulating concrete that we were using and also sort of developing a little bit further for this project. And after some research, it turned out that it's possible, and so we tried to do it. When we designed this house, and it was very clear that it's basically on the one side a closed shell, a really massive wall, and on the other side it's completely open, like no columns, no walls. We thought this will be structurally very critical. The building became this stabiler Bock, we say in German. It was just sitting there, boop. And the structural calculations resulted in such a way that there was, for the whole open glass facade, there was no column needed, nothing. That was fantastic, and that had to do with the triangulation of the roof and of course the capacity of this material, the Thermisch insulating concrete, that it's a real structural concrete. This is a private house, a house for a family, and basically, from my point of view, for a private home, the key feature of the architecture is atmosphere. Mm-hmm. And ultimately, when working with this material, you are approaching a quality that resembles living in an old, traditional stone house. That's actually what it is. You know, it's open, it's exchanging moisture, it's like a little bit also almost like a living shell, because it's concrete cracks, concrete works. We don't even have a skin on the roof. It's purely this one material. You're going to be really living like in an old stone house, and everybody knows the qualities of that. It really has to do with the craft of building a house. We were facing situations, as simple as they might sound. For example, this inclined wall, which is poured against the earth. That's the hill going up there, and this inclined wall, leading to a zenithal light here, which is fantastic in this kind of underground condition here, was quite a challenge to build. Simply because this concrete is very light, so it doesn't really drop into the cast as like normal concrete, and then you have an inclination. And you're on site. The concrete is there. The truck is rolling, and you have an hour time, and then you do it. People involved with designing such a building, and with design I mean also engineering, are not really used. They haven't really had an example for it, and it also comes down to when it's built, the builders on site, they're also not used to this type of work. So it was a really in-depth, almost a very traditional type of building, where the engineers and the architect and the builders on site, and we were on site every day. But it's clear you can build a cheaper shell than this one. But what are you getting in return? So I think the cost factor here was not out of control at all. It's only that you have to find a group of people who's committed to work on it like on a project. So of course there were certain things not fully resolved once we started. Not because we were taking risks, simply because it was not clear in the beginning that these issues would come up. So for me it was extremely important to have a team of planners with me, which I could rely on and know they go through the building process with me. The matter of fact is there is no real innovation to it. It's just a matter of using the right things, sampling them together and going for it, you know, and building it. This technology is still today a sort of one-off technology. Because you're working with concrete, and so wherever you build, the concrete, the cement, the things are a little bit, the components are different. Even the hardness of the water, depending on where you build, is influencing concrete, and it's a biology somehow, chemistry thing. So you have to be aware of that, and you have to have partners who are willing to approach that. Of course, I think when it's repeated more often, you will find a controllable recipe that can be replicated wherever. Well, for me, naturally, the next step would be a larger scale building, because then it would be interesting with larger quantities to research more efficient methods, and with that opening another door to, let's say, you know, market compliable development of the techniques, yeah, because in the end it would simply be fantastic if a percentage of the built environment could avoid being packed in 20 centimeters of plastic, you know, which is ultimately the direction the building industry is going to still. And this material is by far not at the end, and that's what makes it interesting. There's so much research going on. So of course it just needs to be better in the future. Right now it's working as it is, but it's not surpassing by 50% the requirements of today. We are, with this recipe that we're using it complete. We need every square millimeter of compressive strength, we need every lambda tenth. I'm much more interested in a future where houses are built like that than in a future where houses are built out of very, very thin skins, which are like super toxic, and nobody has an idea of how to recycle them, and so on and so on. To see it now there, it's just beautiful, and that's ultimately the goal. And the haptic qualities of this material, which is concrete, but it's not cold. I mean, that's stunning.